Good day, everyone. Welcome to our first jewellery webinar, live from Sydney, Australia. My name's Graham Turner. I'm your host for this webinar, and I'm the Global Operations Manager for Asiga. For those of you that don't know much about the history of our company, we launched the first LED-based DLP 3D printer back in 2011. And it really shook up the industry, and it was a revolutionary product in its day, and it was the first high definition desktop 3D printer released to the market. In 2012, we launched that same product to the jewelry industry in North America at the leading show, which is still the biggest show in North America, called JCK. It's held in Las Vegas every year. And later that year in 2012, we won the Thinking Ahead award for the best new technology by the MJSA. So the jewelry industry to Asiga still remains a focus for us, and it's very much an industry that we still focus on today. Now, our jewelry webinar series will navigate all areas of jewelry, specifically jewelry manufacturing, where 3D printing is an integral part of the process. We hope that this series will provide you with some guidance, some insight, and just to hear how the guests that we have on this webinar series utilize 3D printing in their day-to-day workflows. So over the series, we'll be covering topics from bench jewelers, from CAD designers, from experts in investment casting. So be sure to keep an eye on our announcements that we'll send out when the webinars are available. Now, tonight's topic is 3D printing and the transition of jewelry manufacturing technologies with our special guest, Stuart Radmore from Stuzanne Jewellers in London. Before I hand you over to Stuart, I would like to share some of his background. Now, Stuart spent most of his life in and around the jewellery industry alongside his father, who's a well-known and regarded jeweller, who started Stuzanne, a bespoke jewellery manufacturing business based in Hatton Gardens in London. There's a key difference, however, between Stuart and his father, other than the obvious, but Stuart took a different path and was drawn to technology and how digital CAD/CAM processes in particular could be adapted to jewelry manufacturing, yet still complement the traditional skills and the traditional values that have been around for thousands of years. After many years of at the bench and pushing the limits of digital processes, Stuart has found a balance that has helped streamline their business while maintaining the productivity and the highest quality that them and their customers expect. The format of this webinar will be for me to shortly hand you over to Stuart, and after his presentation, we will have some time for a Q&A. So please make sure that if you've got any questions for Stuart or for me, please put them through on the chat or the Q&A section in the webinar, and we'll do our best to answer these afterwards. Now, we'll try and keep this down to an hour as we've scheduled, so let's get started. Stuart, it's an absolute pleasure to have you join us today. Then the stage is yours. I'll go backstage and I'll leave it up to you.
Grab a coffee and relax.
Yeah.
So, hello everyone, and welcome from the UK. Basically, I'm in London, Hatton Garden, the London Jewellery Quarter. Today we're going to be discussing CAD/CAM and how Asiga has helped me along the way and how it's improved and benefited the business, basically. So we're going to just dive straight in. Let me get myself nice and small. So Stuzanne, so as you already heard, my name's Stuart. Stuzanne was founded in 2000. We're a family-run business. My father is currently 63 and he's been doing it since he was 14. He's been in the business for a very long time. And there's always a huge debate where CAD/CAM comes into the industry. Is it destroying it? Is it making it better? And what is the best benefit for it? So I joined the business. I wanted to join when I was 18 years old. He said, finish your college degree and university degree in IT, then come into the business if you still want to. So that was about 8 years ago. I started finally formally being in the business. And my direction was I I liked being at a bench. I liked trying the bench, but technology is where I really, really enjoy. I managed to see an opening within our business to improve it and to offer a different service, which if we didn't start offering, we would have been left behind. And as a business, you never really want to be left behind. So we have technology and tradition. The main two ways are handmade and handcrafted. And I put a little bit of bullet points on what it is and basically what defines the two. So handmade obviously takes more time to do multiple pieces. But if you're just doing a single piece, like a single stone or a freestone, it's much, much quicker to do it handmade than CAD, cast, CAM process. I can only speak about the UK market when I talk about the way that we do things in the UK because it's the only market that I have experience in. I know that abroad there's a lot of jewelers who do everything under one roof, whereas in the UK we have mounters who do metal work, we have setters who set the stones, we have jobbers what do the sizings and the repairs, and then we have polishers who are dedicated to their whole row, just the whole roll, just to make the piece look beautiful. And that's basically the main sections within the UK as I see them. Expertise wise is you can be doing jewelry for 4, 5, 6, 7 years, still not be classed as a graduate or a master of the trade. There are apprenticeships what last 5 years where you still only learn the basics. People who are doing the business for 50 years are still learning the business. And the use of components in handcrafted jewelry has been going on for a very only difference really is that the way that we make those components now. So the components is basically if you've got two parts of the ring, which is the band or the shank, and the head or the collet, depending on where you're from, depends on what you're actually talking about. Sometimes they're made by mounters where they'll turn up silver, brass, or a base alloy and make molds from it, then wax inject it, then cast it and clean it up. That's the way that it's been done until CAD come along. CAD really has improved that area of the jewelry industry because of basically, if I have to have one ring in every single size, in every single stone head size, and every bit has to be unique, that is a lot easier to do because you can make the components in any of the CAD softwares, print them on the 3D printer, and then produce it from casting rather than having to make a mold, clean it up. And it's really sped up the industry. Granted, there are some people who say that it's slowly destroying the industry because of someone who hasn't necessarily sat at a bench can design on a computer. The programs will help you along the way and design, and that's some people's aspect of the industry. Personally, my experience from it is that CAD has improved the industry. It's like a tool in a toolbox. Everyone has a use for it. You've got true handmade, which is a big debate. So as you can see in my picture, you've got a 3mm square bar of metal, a stone, and a wrapped around collet, all made from bars of metal sheet. You can melt it down, and that's what we call handmade. The reason that we don't class something made from components, even though they're put together by hand, is because of basically machinery or casting or done another way in the UK. The skill set, obviously, to clean up a casting and assemble it, you'll have not necessarily less skill because someone who has spent all their life learning all the traditions, learning how to do it, and everything like that can assemble components. But in industry, we see that if you're just cleaning up castings and assembling them, that it requires less learning curve, less skill set basically. Casting obviously is the major thing of handcrafted, and it's what's really pushed the industry quicker. That's because of to get something cast, you can do it the same day, get next day if you know the right. And that really has sped up and introduced a new level the jewelry industry. A lot of pieces now, even big brands like Tiffany, Cartier, Graf, are actually just cast pieces put together um, because of its certain cost effectiveness, what pushes it towards that way, rather than handmade takes a longer time, it takes more labor, and there's a lot more metal. When we talk about CAD within the industry, there are many programs what can do. We've got Rhino, which is the base software on Matrix Gold, Panther 3D, and Two Shapes. They are actually built directly on top of Rhino as plugins. Pixelogic ZBrush was never a software for the drawing industry, but it's actually being used a lot more because of for organic design. Whereas wax carving was the way to make an organic lion or a frog leaping over a mountain, or something which is really truly not done by engraving metal. They usually do it out of wax. Redesign was the first software on the market that I know of which done true parametric, where you can do a ring in a 75 pointer stone and then change it to a 1 carat stone and the head. Now with Matrix Gold and Panther 3D, they're all going down that line, making our lives as jewelers a lot easier. I'm not saying that all jewelry is made that way. If you're doing a mass production piece, or if you're doing anything which is going to be hundreds of designs or have to be done in multiple designs, that's the way to go about it. Because you can have one master file and do a million different options and configurations for it.
Stuart, sorry,
yes.
I'm sorry to interrupt. Can you, your sound keeps dipping in and out. I'm just wondering whether you could just move your mic a little bit closer, maybe. Sorry to interrupt, but
No, it's absolutely fine.
That's much better. I think there's
Yeah.
a few people who can hear similar to me. Great. Back
Okay,
to you.
perfect.
Thanks.
No worries. Sorry about it, everyone. I do drag on a bit, and sometimes I dip my voice, but hopefully this is a lot better. So when we use CAD, we obviously use it as a tool to help and improve designs and make it quicker for ourselves. So on the left-hand picture, you can see that I drew the design on the right-hand side, and I made it as a two-piece casting. The reason that is because of the bottom part of the ring is actually in yellow gold, and the top of the ring would be in white gold, so it's two-tone colors. Whereas we used to have to make that out of wax and cut it and cast it and then fit it together afterwards. CAD's really improved that design where we can just draw it in the program and it will all fit together, and we won't actually have to worry about absolutely anything. It's actually reassuring that the Sega printer that we have, the Max X, will print with such accuracy that we just print a file, plug it in, and we don't have to do any worrying about anything that was going to actually work. When we talk about drawing in CAD, obviously with the advantage of technologies, there's tolerances what have to be adhered to. There's ways that we have to allow for shrinkage. Not only shrinkage in printing. So if you design something which is 2 mil, if you haven't allowed for shrinkage, once you've printed it, it could be 1.98, it could be 1.97. And obviously within jewelry and diamond setting, it's very important to keep the thicknesses there. So when I draw anything in CAD, I allow 0.1 millimeter extra for shrinkage in the printing, and then I increase the model before I print at 1% to allow for cleaning and casting, the cleanup of the castings. This all depends on the materials that you use. So that's going to be a discussion in another slide, because of I could talk for hours about what resins you need to use, because of I've tried so many of them. And that's the fantastic thing about their Sega, is that it doesn't matter what resin you use. If you want to use a Sega resins, it's perfect. If you want to use other resins like Envision Tech, Blue Cast, Power Resins, DTAX, you can use them all. And it all depends on what you're going to use them for. So we're going to go on to the next slide, which is actually about printing, which is pretty much where a Sega comes into this whole entire conversation, where when we design it to either show a customer, to create from the CAD file, and sometimes it's just for us to actually just to see where it fits and how it goes all together. So when we print the design, depending on what usage we're going to have, depends on what we print it in. So there's two main types of resins on the 3D printers that we use, and it's castable and non-castable. That's purely because of, if we're going to just show someone a piece of what we're trying to make, there's no point printing in castable resin because the cost is slightly higher on castable resins, and it's more harder and tougher to put onto someone's finger, the non-castable, rather than the castable resins. So it's, in my mind, it's logical just use non-castable. Some people don't bother doing that because of, they don't want to change the settings on the printer, even though it takes 2 seconds, or they're too lazy to change a tray, which is really quick anyway. But I can't talk about everyone. I can talk about myself. I do change what resins I use depending on what I'm doing. It's also depending on what materials we're casting in that we have to take consideration on what resin we use. And it depends on who we're giving the casting to, if we're doing it in-house, if we're giving it to an external casting house, and how that all happens. So, for example, what we do for platinum cast is we use super wax, which is a resin made by a Sega, which is basically comes quite solid, and you have to heat it up and put it into the tray. And once it becomes liquid, you can print from it. Whereas resins, they come as liquid. You shake a bottle, you pour it in. If we're printing and casting in platinum, we lean towards super wax because it burns out quicker, it burns out nicer, and it's fantastic to cast platinum with. Whereas if we're manufacturing in gold or silver or any other alloy, we'll stick with a basic resin because of, we know that whoever we give it to will be able to cast it in no problem. For some reason, resin hasn't made it onto the market for platinum castings because of the investment that people use, or the chemicals what they got to use, or for an external source, an external reason, because of, it's not down to the printer or the material, it's down to the technology which is there to be able to cast in platinum, because the melting temperature is a lot higher in platinum than it is for gold. And that's something which is currently holding the industry back a little bit in my eyes. So that's why if you ever have to do anything in platinum, people use super wax or wax jet printers to do it, because of, that's the only way to get the result that you need to have. So as you can see on the examples on the right hand side, the top left red one is super waxed, and they were printed by James Ray Adams, and they're extremely beautiful. It's a hard material to work with, but the end result's always worth using that. On the top right is EnvisionTech WIC 100. That was printed on the Sega Max X. So it just shows that you pretty much don't actually have to use an EnvisionTech printer to print their material. Bottom left is Blue Cast, a Sega original, and bottom right is X10. And the amount of detail that you can get in designs nowadays is incredible. For example, if we was making a single stone in the top left image, we could make that quicker by hand than the whole process of casting. But if we was making the lion or the figure from Mulan or the fine filigree on the bottom right, we wouldn't do that nowadays by hand. It could be done by hand because of the skill set and the technology has always been there. It's just a lot quicker to do it on 3D printers and CAD. You have moldable vulcanized rubber materials that, for some reason, if you want to make a mold out of a 3D print rather than using a material to cast, you can do that now. So when I say about Stuzanne as a company, we will always bend to the customer needs. We're known for our handmade bespoke, but over the last 6 years since I've joined, we've started to move a lot further in the CAD industry and really defining the user experience, where we can actually draw something and show them pictures and get a sample on their finger within an hour. It really does help boost sales, because of no one really visualizes as much as they used to. They want to feel the product in their hand. They want to see how it sits on the finger. They want to see how it curves up. And sometimes that's just not possible with images. People prefer to have it on their finger. They prefer to really see where it's going. And you can't blame people for that. It's a tool to be used. And that's why we now generally, every single design or every consultation we do with the customers, we do an image in CAD, we send the image. If they have any changes, we do them really quickly. And it's reduced cost and labor and everything, which is very important to us as an industry coming on, because gold's not getting cheaper. It's actually, if anything, getting a lot more expensive, especially palladium and white gold in the UK, because of the UK is good in some reasons to manufacturing jewelry, especially because we don't allow nickel in our jewelry anymore. We don't allow it to be manufactured that way. But it also does give us a disadvantage because our costs will be higher because palladium costs more. With the 3D printing, what is best, that is a massive debate. You pretty much will have people argue blue until they're blue in the face that this is the best way of doing it, this is the best way of doing it, or no, you're both wrong, you should be doing it this way. But at the end of the day, it's whatever works best for you. What works best for us is printing a sample, putting it on someone's finger, then print it in castable resin, send it off to be cast, and then that's the process done. If they want it made by hand and they don't want it made by CAD CAM, then they don't have to. It's quite simple. When it comes to materials and casting houses, because this is very important in the jewelry industry, is the casting houses, is that basically they've been using wax for years and years and years. The way that that's been produced has been around for, well, probably before I was even on this planet, if I'm honest. I'm only 31. And they're just used to having it set up in that way, that they set a certain oven, they set a certain temperature, and they just manufacture that way. With resins coming onto the industry around, well, Graham said it was 2012 that they launched the printer. I've been using resin since 6 years ago. And even now I'm finding casting houses what don't cast resin. And for me, it's, if you don't do that or you don't invest time in actually moving with technology, you're going to be left behind. You're not going to be able to keep up with demand if you're not doing what the demand is. Over the last 2 years, the amount of people that I know in the trade in London using resin printers has gone through the roof. Whereas they used to be, oh no, we've got to use wax, it's better, the casting houses can do it. Now a lot more people are going towards the resin way of doing it because they're realizing that cost effectively, it's incredibly cheaper, it's a lot better, and it's in a good way. When we talk about how the Seagull Max has helped us, labor time is a big factor. London is stupidly expensive with rent, services, travel, food, everything in London is quite ridiculous in my eyes, but that's a whole entire different debate. But what that does do is push that cost onto your customer. And if you're going to do something by hand, you've got to charge, let's say, £75 an hour to do something, then they're going to be less inclined to actually like give you the job to go ahead. And the way that I see it is actually being based in London and in Birmingham or in another part of the UK will just determine on your cost, because of it ain't going to be about the gold, it ain't going to be about the way that you produce it, it's going to be about how much it physically costs you to run. So 3D printing has really opened the doors for us. We've been able to compete more and more designs. We're going to be able to compete more in production. If people want anything done by casting or CAD and they don't have the budget for handmade, it's open us to say, yes, we can do that business. Yes, we want that business, rather than saying, unfortunately, we can't do the job for you. And that is a major thing for business. When I talk about time frames and lead times, we do a lot of big necklace pieces or big bracelets, as you can see in the pictures in front of you. And whereas we used to ask 4 weeks labor on them, we're down to 2 weeks, and some of them we can knock out in 7 days now, just because of the advantage in technology and 3D printing and how it's helped us as a business to become more competitive. And I'm not being funny, but when you can actually save that amount of time and that amount of labor, you can invest it in other ways and really improve the industry. We are saying basically yes to everything that we can do at the moment. The only real time we say no is if we've got so much work on and they want it in 2 days. And sometimes you just can't deliver to everyone. Metal loss compared to handmade is incredible. Whereas with a handmade job, you can lose anything from 3 to 25% of the metal you started with just from doing a single job. And that is no good, because of why would you want to lose that amount of money on lemel or scrap or unusable pieces when you can do it a different way and keep your costs down? It really does help you keep the costs down, more competitive, and just save money. You know, end of the day, everything's about being more business savvy, being more cost conscientious, and just being able to offer what you really want to offer. When we do any big projects, the first thing that we do is that we want to make sure that you can fit it on your neck and you can use it. For example, a piece like this, where you I'm trying to find where the camera can see it best. But basically, a piece like that, where you have to try everything out and see it fits and it works and it fits the neck okay. With 3D printing, we're able to actually do that, and we're able to make sure that it works. And just by being able to do that and show a customer, yes, it will work, yes, we can do that, gives us the advantage over other companies. Whereas they all say, yeah, we can do it, but they might not be able to deliver. Where we can put it on the customer's neck and show them, okay, that's a nice fitment, that's good to go. Then that's basically what we're aiming to do. If we can do that with prototyping and 3D printing, then it saves us a lot of money on, okay, so we're doing the connection that way, we're going to link it that way, the clasp's going to go there, rather than doing that in the handmade process. Whereas if anything goes wrong, then we have to kind of go back a few steps and rebuild or make a new one. When I say about chaos, unfortunately, anyone who's dealt with us in the UK know we work on stupid deadlines. We work on deadlines which pretty much you're in constant stress most of the days, because of, you're like, will I make this deadline? I've promised this for this date, and will it work? With 3D printing, a classic example right now is that I get into work at 7 a.m. If I forgot to put a print on, if I forgot to put a cast in, I can give it to the caster at 10 a.m. the latest, because I've put the printer on at 7:30. It's off the printer by 9, with the cast by 10. I have the metal back in my hand by 1 or 2 o'clock the same day. And that way, even if we are running behind on a project, the customer never knows, and it's delivered in perfect looking condition by 4 or 5 p.m. the same day, just by having this technology available to us. And even if you're not doing it on that amount of stupid deadline, you can actually do it a different way. Whereas you give it to a caster on a Monday, it comes back on a Wednesday, and you're just, if you're organized, you actually can be really ahead of yourself and have a lot less costs. If you're doing chaos like we do, it does sometimes cost you a little bit more, but still save yourself a lot of money compared to doing it by hand. And when I say the major benefit for us is, if we've got to 10 rings in a short period, let's say we agree to a job on Monday, we've got to deliver 10 rings on a Friday, we can actually do that easily with CAD CAM and using the Seagate X printer, because of, we draw, we print, we cast, we clean up, we set and polish, and it's just really quick and easy. That's how CAD CAM has really improved that technology and our experience as users. And the biggest thing with us is that I started in the company 6 years ago. And unfortunately, I made the mistake of first buying a cheap Chinese printer, and I'd done the printing and learning all my mistakes on there. Then within 6 months, we bought the Seagate Max X. And then I no longer had to worry if a print was going to finish, if I had to stay up all night or do a delivery the next day. We actually had it ready and available. I didn't have to worry anymore. And it helped a lot with your mentality, because of, if you're worrying about things of, will print work, will the design work, will it come out correct, you've got the technology there now just to just to basically put it on. Okay, so that's too thin. I'll do it again slightly thicker. Okay, that's perfect. I'll continue with it. It actually does make your life a lot easier, and you stress a lot less. And one of the main things with manufacturing is learning the printer, learning your workflow, and learning how to progress as an industry. When we was trying loads of different materials, we had to actually find the material what worked best for us. It wasn't necessarily what worked best for everyone else. So we spent a lot of money on different resins and different profiles and testing to see what was the perfect one for us to do the job that we needed to do. And I remember, I think it was late last year when Asiga released a update to my printer, and it reduced the print time by 25 to 30%, which is huge in the jewelry industry. You can actually do a lot more. And it was like, okay, so I've got the printer, and it's even better without having to have any changes done to it. And that really truly made our lives a lot easier and a lot better in many ways. When I was staying one night to print 245 different collets for a necklace, it reduced it by 3 hours, which is, for me, funny enough, 3 hours more in bed. So I was actually quite happy about that. When it comes to, well, it's just helped us a lot. I can't say that we do everything by CAD, because that's not true. We actually do most of our production, 90% of it, still by handmade. That's what we're known for. But that 10%, what we do by CAD CAM, would have been business that we lost. We wouldn't have got the deal. We wouldn't have got the go ahead. We wouldn't have got any benefit from it. We would have done the quotes. We would have spent time and labor to actually just give someone a price and actually not benefit from it at all. So that is actually great. In terms of metal loss, we've gone from losing 450 grams of metal a month down to 325 from doing the cast pieces. And that is a lot of money saved and put in the bank. I got to say that it's helped. When I say that it's been a long road for us to find the best ways of doing things and best ways of doing certain aspects, I'm going to tell you what I learned along the way. And this is what's going to help the most, really, is if you own an Asiga, if you don't own an Asiga, or if you're thinking about an Asiga, these are the things that I use on mine, because of this actually helps me do my job a lot easier. I went from using the standard trays on the Asiga to using audio trays where I've got a lot thinner FEP. And this was mainly just down to learning designs. So on standard FEP, everything was printing fine. But going to audio trays, if I've got a fine filigree design which has got 0.3 wires, the audio tray has less suction, so it just helps me do a lot thinner and crazy designs to enable me to do the best for the business. In the terms of metal, you can go to thinner designs, you can go to signets with chevalier patterns, you can do seal engraving a lot better on an audio tray than you can a standard tray. Another trick, what I was told a long time ago, was that if I put a 50 micron film on my glass underneath my tray, use an audio tray, that the suction forces are a lot less, which actually enabled me to reduce my print time on some resins from an hour and 45 minutes down to an hour and 15 minutes. Save myself 30 minutes on a print is absolutely massive, because of that way I can actually do 9 prints a day in a normal day, or 10 prints a normal day, compared to the 7 or 6 that I was doing. In the Composer software, I love and I hate Composer, but we'll talk about support overexposure first, and then I'll tell you the reasons why I love and hate it. So there was a feature in I think it was either the latest Composer or the one before, I can't remember when it came into play, but it came into play and I'm absolutely over the moon with it. The reason being is because if I can put a main sprue at the bottom of a shank where I need the metal to flow on the casters, and then at the top where there's a little bit of detail, but super fine supports, 0.1 millimeter, 0.15 millimeter, it support a print and come out. The reason that I said that I love and I hate Composer is because of, for me, it's not the easiest software to use. And that's, in all honesty, I use it to send the prints to the printer, but I do use firmware a lot to do supports. I can do everything that I want to in Composer. It's just with my workflow, I do it better elsewhere. New feature, what I don't know if it's fully released yet or if it's fully working. I've tried it on a few prints and it worked amazing, but I don't know if it's specific to certain printers. So this, I use different layer heights. If I've got 50% of a ring, which is just a plain shank, and the top of the ring is where all the detail is, filigree, trellis, flower designs, anything which requires a higher layer printing quality, then I change it to that because of you just get that extra little pop in the design. Orientation of the prints. So this is something major what pretty much should be taught by everyone and to everyone is when it comes to supporting prints, there's always the best way of doing it. And there's always the best way of doing certain things. With that point in case is that you need to learn how, what, and what best for what you're trying to achieve. And that is basically the most smoothest print that you can do and the easiest way of doing it. And for us, if we're printing most designs on a straight up, then it is good and you get a nice quality. But at the same time, it's not always the best way for big heavy rings. For big heavy rings, it's best to actually have it at a diagonal or at 25 to 30 degree inclines so that you can actually have it nice and easy and a smooth print. So where you're going from a thick part of the ring to a thin part of the ring, you don't want the suction force to be too high. So if you've got a big signet ring, then you want to basically print the shank at an angle so that it slowly increases what you have to do rather than it going absolutely mental and creating a layer line on the print. Sorry, I dropped something. And that's basically a very good hint, is basically to angle your print so you have less layer lines and you have not a thick line going across, and then that's a lot better. When it comes to CAD CAM and casting, you want to round your edges on engravings or lettering or anything where there's going to be a sharp edge. You want to round it off even a tiny little bit, just so that you don't have fallen in investment breakouts and you don't have a bad design. You really don't want that to happen because of it takes you longer to clean up a piece, longer for a nicer finish, and at the end of the day, that's really what you don't need. You kind of want to be able to just clean up a piece within 25 to 30 minutes, give it a final polish, set it, and then it be on its way. You don't want to actually have to spend ages threading a piece, cleaning it up, and doing parts that you don't actually need to do. When you are at a certain level, or even if you're just starting out, the basics of CAD CAM you have to learn. And there's a great piece from Stala what gives you the basic outlines of what you should follow when you're designing in CAD. It gives you a minimum depth of engravings, it gives you the certain thicknesses that you need. And all these things will help you along your way. Myself personally, I didn't actually go to a school to learn CAD. I was fortunate enough to be able to pick up software just by watching YouTube videos or just playing around and clicking buttons and seeing what happened. But to truly understand what I was doing, the bench knowledge is fundamental, because of if you've got a certain stone size, you don't want the claws to be too thick, you don't want it to be too thin, you don't want it to break away, you don't want the ring to disform. And that's why 3D printing and prototyping is absolutely amazing, because of it takes that guesswork away from what you're doing. You draw on a computer, you print it out, and then you can see, well, I made a mistake, or no, that will work. Because of every design on the computer screen looks absolutely massive. Whereas if it's in person, you can see, okay, yeah, that is a little bit too thin. That's going to break on someone's finger within 2 to 3 years, or this person want to get 10 years wear out of it. That's where printing will really help you and move along. Unfortunately, I've rambled on for a long time, and the next slide says question and answers. So this is where I'm going to head back to you, Graham, and if you've got any inputs, and we'll take it from there.
That's great. Thanks, Stuart. We've got a few questions for you. So the first is, do you use two-step exposure?
There we go, turn the mic back on so you can hear me. Yes, I do use two-step exposure, and I find it very important and very imperative with what I do in designs. The reason being is because of, if you've got two-step exposure, you can actually overexpose one part of the ring and then underexpose the other part of the ring. The reason being is that certain designs will require you to have a certain level of detail, a certain level of degree, and that helps you massively. So it's something what I would recommend to everyone to do, is to learn how to do it in the program, into Composer, and just give it a try. You know, you'll be amazed on how thin and how easier you're going to have to clean up the supports over having thick, heavy supports.
Have you tried the new multi-range feature in Composer?
So yes, the multi-range Composer feature is absolutely amazing. It's something that I think Stephen Wise in Germany was testing out and seeing how it was going, and it's incredible. For certain areas of the ring, you actually want it to be a lot finer, and in others, you don't want it to be. But I've only ever used 2 ranges. I know that you can add more than that, but I've only ever tried 2 ranges.
Yeah, okay, great. Which CAD software do you use, and which software would you recommend to a newbie, so somebody new looking at getting into CAD?
Okay, so that's very interesting. It depends on what you want to go into. The reason I say that is because if you're going to do organic jewelry, then ZBrush is where you want to go. You want to learn that first, and then learn the traditional ways of making jewelry, because of ZBrush out far amazing, much better than Rhino 7 with its new sub D, with any tool in Clayo and anything like that. But if you're actually just starting and you want to learn like freestones, single stones, halos, then I would either choose Panther 3D or Matrix Gold. Personally, there's a big cost difference between the two, but I own both of them, and I do some stuff in Panther and I do some stuff in Matrix Gold.
Okay. What would you do in Matrix over Panther and vice versa?
So with Matrix Gold, it is very good in single stones cathedral rails, which is basically a lift up shank, the way that we say it in the UK. And that kind of detail is very easy with their builders. Like if I'm doing any halos or any big heavy rings, I lean towards Panther. The Panther hollowing tool is a million times better than Matrix Gold, a million times. It's actually to the point where I would actually buy Panther 3D just for that tool, because you can reduce 30 to 40 grams off of a ring simply and nicely and beautifully, and then have a plate created within the software to actually fill in the back, so it's just not a huge hole.
And just so it's clear to those who aren't familiar with the pricing difference between the two, what does that look like in, well, if you just use pounds sterling as a...
Yeah, so if I use sterling, Panther 3D is 2,500. Matrix Gold, I think at the moment they've got a deal on, and it's around 6,000. Obviously, they both come with Rhino, and that's where your base is. And they're all, you can do everything what the program's doing. Rhino, it just takes you longer. And Rhino is £900. ZBrush is £700. Free Design, I don't actually know because I haven't looked at it recently. But the last time I saw it, there was different packages. One was 4.5, one was 6.5, and one was 8. So there's actually quite a big cost involved with jewelry CAD software.
So it's advisable for, how would you advise somebody? Would you just, are demos available? Can you get like a trial license or?
So yeah, whenever you try anything, and this includes printers and that kind of stuff, you always want to see a sample of what it can do. With printers, it's sample prints. With CAD software, Panther gives you a 30-day trial. Matrix Goals give you a 7-day. Rhino gives you a 90-day evaluation, which is amazing because of 90 days you can learn a lot. ZBrush, they don't offer any trials, unfortunately. They should do, but they do a monthly pricing now, so you can actually try it on a monthly basis, and I think it's 45 or 50 pounds a month.
Yeah, okay, and you can output from ZBrush, you can output your STL, so you've got that data on, or the ZBrush file, so you've got that data on
Exactly.
your own
And
file, have you? Yeah, okay.
yeah, and
That's
the
good.
way that I use ZBrush is basically I design, let's say I've got the seal engraving on top of a ring, or a ring design where it's got a line on top or something like that. I do it in ZBrush, and I export it into either Matrix Gold, Panther, or Rhino, and then use the two programs together. It can all be done in one, and ZBrush is actually making huge leaps and bounds currently for the jewelry industry, which is amazing.
Yeah, good. Well, this sort of leads on to the next question that's coming is, which software do you use? Is this where you blow everyone's minds with this long list? So we'll have to bring out them.
Unfortunately, yes. I think I've spent well over 20 grand on software, if I'm honest. That's just trial and error. So my everyday program that I use is Matrix Gold, because of a lot of our designs are quite generic and quite simple, and I've got a lot of masters saved up, so it's quite quick to change them around. I use, let's go through the list. I use Matrix Gold, I use Panther, I use ZBrush, I use Rhino, I use 3D Coat. 3D Coat is basically not a CAD software to design in, but I use it just to round off little edges on designs to make it easier for casting. But the two what I use every single day is Matrix Gold and Panther. ZBrush, I try and stay away from it because of, I got to say that I've been trying to learn it for about 6 or 7 months, only a few hours here and there, and I still haven't picked it up perfectly. It's just one of those software it doesn't work the way that my brain works.
Yeah, okay. So there's which resin would you suggest using for Cobalt chrome casting?
Cobalt and chrome, I would actually lean towards using super wax or supercast HD. Just with the way that super wax is, it melts out a lot easier and a lot cleaner, so you actually get nicer, crisper casts. Cobalt is mainly used, I believe, in the American market. We don't use it much in platinum in the UK because it's magnetic. And then basically, when you do your Lemore sweep, you have to run a magnet over your metals to make sure that nothing magnetic goes in there, otherwise it destroys the machines that you get melted away from.
Okay. And would you, aside from Asiga materials, are there any other third-party resins that you'd recommend?
Oh, definitely. So last year or earlier this year, EnvisionTech released their materials to the market. So the Wick 100G takes a little bit longer to print, but it's absolutely amazing. It's a good quality material. Or I would use Bluecast Original, which is about 3 years old now, 4 years old. I still find from the way that I do working, it prints out and casts the best.
Okay, great. So I'm just trying to structure some of these questions so we don't go backwards, but it says, in your opinion, which is the best casting resin on the market today? Bearing in mind you've not tested the new Asiga resin, but we won't talk about that yet.
So basically, yeah, that's really difficult.
I suppose it comes down to which metal you're casting in, does it? And
it really does.
Object that you're wanting to cast.
So basically, what I use the most of and what I print the most is Bluecast Original. The reason being is that I don't cure it. I literally clean with alcohol, I run it to the cast, and I save myself about half an hour worth of labour. And the cast that I currently use in London, he loves it. He prints and casts with it as well, and it just works beautifully for what I'm trying to do. But that's one of those questions where it's very down to your personal opinion. I know other people who've used it and don't find it as good as I do. I know other people saying you're crazy, you should be using this, but it's literally how long is a piece of string. It's one of those huge debates that there's 50 million materials worth on the market that you can use, and you kind of have to choose one of them. It's like I like dark chocolate, I like milk chocolate, I just like chocolate, so.
Yeah, that's fair enough. Well, for them linking to Bluecast, then it says for Bluecast, which investment do you use? But I suppose there's another question here: is are you casting in house? Which I think you've alluded to that you're not. With the Bluecast investment or the cast that you use, which investment do they use? Do you know? Can you give any?
Yeah, I can tell you what they use as well, because unfortunately I did start casting 6 months ago. Where I'm just learning, I kind of give it at. So personally, I use Prestige Optima, made by Certus, just because of it's nice and easy to do. And then when you clean out the flask, you dip it in water and it just disappears. So that's really good. My casting house uses Roman from Randolph. They use R&R plastic cast, I believe. X-Vest, which is made by Bluecast, is absolutely amazing material. It's more expensive than normal one, but it is great to use. And then basically you got Verifest for platinum. So it's also down to what material you're casting. So for gold and silver, I would go for plastic cast. If you're going to try and do something in a real rush, I'd use X-Vest because you can cast in an hour. But if you're doing platinum castings or cobalt or stainless steel or any of them ones, I would use Verifest PT. And they're made by Certus.
Okay, great. There's one here. Have anybody ever been running Matrix Gold in Rhino 7?
So that's a very good question. So Rhino 7 got released officially to the market last week. I've already upgraded both my Rhinos to it because of the technology. What they got in it is absolutely amazing. To answer the question in short, it is no. The reason being is because of with the way that they design these programs, they've got to check compatibility before they can do it to anyone. But I can tell them with great confidence that I've been told that Matrix Gold will be running on Rhino 7 as well as Panther 3D. I think Panther 3D have already been working on it in the background from the last conversation that I had with them.
Okay. And I suppose this one's aimed at me. Why not talking about the new resin? The new resin from Asiga is called Supercast X. It was actually we had a supply chain delay, so we announced it prior to it being ready on the shelf. So we will have that bottled and ready on the shelf by next week. So there'll be some more official announcements next week. And that material, I was chatting to Stuart before this webinar. That material's it's sort of a combination between super wax, so our waxy material, and our more robust materials like super cast V3 or HD. So it's a bit mixture of a resin and a wax, but we find that we've got a very good all-round castability performance out of that material. So we're really excited about it. We really feel that we've got a really great material there. So more details on that will come next week.
I can't wait.
But yeah,
I think everyone can't wait, honestly, because we've been hearing rumors, and it's like, just give it to us.
Yeah. We sort of got caught out a little bit, so we can't turn back the clock, and I'm sure most will be happy to see this year behind us. But we will. Yeah, there'll be something announced by next week because that's when it'll be on the shelf. So we'll let you know. After printing, are there any tricks to get the resin to cast?
Sorry, can you repeat that?
So after printing, are there any tricks to get the resin to cast? I presume that's around like for post-processing. Is it washing or curing? Is there anything that, I suppose that comes down to which material you're using and the suitability for casting and the investments. I think with casting, there's no one single scenario which covers all applications, all geometries, all environments. Casting's a real art form. So there's special handling in every scenario. So it's quite a difficult question. Yeah.
The general, I would say, is make sure you clean all the excess resin off of it. or the excess material. If you've got anything left on there, it's going to come out in the casting. So make sure you clean it properly. That's the only thing you can do to every resin and every wax on the market, is to make sure you clean it properly. Maybe use 2 or 3 alcohol baths, and that's it.
Yeah, and I think it's also I think a lot of the time there is the focus is on whether the material is suitable for casting and the investment. But you touched on it earlier about the design, so softening edges. Anywhere where there's a sharp edge in investment can create a problem. So you might get chipping in the investment, which may flow with the metal and look like porosity. So I think the design of the object is actually as critical as the resin being used and the investment being used as well. So I think there's a number of factors there, but I think for the person who's asked that question, I'd first look at go back to what Stuart said earlier about the design and softening edges, and maybe look at that and then assess the materials and the investments. What value do you use for border with and two-step exposure, fill exposure, and noise to achieve accurate dimensions after post-curing?
Wow, fill exposure for that. But unfortunately, I haven't touched fill exposure. I left that the same. But with me, when I use two steps, exposure is literally just the layer heights and the support exposures. They're the ones I play about with. I personally haven't touched fill exposure.
Yeah. Okay. I think those questions, it would be really good or you could actually open up a technical support ticket and discuss that with, I presume this is coming from an Asiga customer, so somebody with an Asiga printer. You could actually open up a technical support ticket with our tech team, and they'll be able to guide you there and provide some advice. So why do we sometimes, with some resin, get chipping on the same design, but when using super wax, we get no chipping? Is it because shrinkage enlargement of the resin whilst it's burning out?
Yes, in short, in my experience, because you got to understand that every single resin burns out in a different way, and depending on what area of the burnout that it does, depends on how rapid the expansion of the gases is going to be in the burnout. So with super wax, most of the material burns away at a very low temperature on the initial ramp, where with resin, it doesn't burn out at the same temperature. It's a lot higher, and it depends on how quickly they ramp through that stage, depends on how quickly the gas is going to expel. And that's why with super wax, you don't get actually chipping or any problems during the burnout, whereas on some resin designs, you will do.
Okay, thanks, Stuart. So there's no other. If you've got questions, send them in now, because I think we're now on the hour. So if you've got some, send them in. I'll just carry on to just to find some different slides here. So I'm just going to for those who are interested in keeping up to date with Asiga's activities and future webinars, we want these webinars to be useful. We want them so you can watch these and have something to take away, something which you may not ordinarily either have time in your schedule to do, or you've not yet spoke to the right person. We are inviting really key users into our webinar series, and we're really fortunate to have Stuart here with us today talking about his experiences. So we hope that this will continue, and to stay up to date with Asiga activities, you can do so by following any of our channels. Registering for our newsletter is probably the best, but for those on Facebook and other social media networks, then you can follow us there. There's no other questions have come in, Stuart. So I'd just like to say a huge thank you for taking time out of your schedule to do this so close to Christmas, especially because I know that you're busy, and I just can't thank you enough. I think that's been really great. It's been good hearing your experience, and just those little tricks and tips that you had on that slide was really good. So thank you very much for your time today.
Thank you very much for having me. Anytime I can help, if anyone wants to message me, they're more than welcome to, and I'll help the best I can.
So I think you can find Stuart. Stuart's you'll find him on Facebook in the Seeger Jewellery Experts Facebook page. You can visit the Stuzanne website. It's just www.stuzanne.com, and you'll find all the you'll find more details there. The next webinar that we've got coming up for the jewelry industry is with Chesco Diaz from Spain, and he's going to go through design and manufacturing with the Seeger Max. So that is on the 3rd of December at 10 a.m. Central Europe time, so local time in Spain. So we'll send out an announcement for that soon. So really, that's a wrap. I'm really happy again, Stuart, that you've been able to share your time with us today, and keep well. Pass my regards to your father and the rest of the team at Stuzanne, and yeah, we'll chat again soon.
Thank you very much, and lovely to be here.
All right, thanks everyone for watching. We'll see you next time.